everybody, Kurt with Two Brothers Hobby, and today we're going to take a look at the Zipper, which is a new aircraft released by Hi-Tech into their Weekender line. Now the Weekender line is meant to be little time on the bench and a lot of time out in the field flying. And so it's a P2Go kit, meaning plug in to go. All you're going to need to finish out your Zipper is your transmitter. We're going to use the Aurora 9X. A receiver, we're going to use a Minima 6L, a 6-channel receiver, and then flight batteries. And in our case, we're going to use a couple of Thunder Power 480 milliamp 3S LiPos. So with all the pieces we need here, everything else you see comes in the kit. Now what you're going to notice when you first open up the box is that it's unfinished. So the Zipper is not painted at all. All the key components are installed, the brushless motor and the ESC, as well as all the servos, but you're going to need to do some painting if you want to make it look a little better in the air. It does include some basic stickers, which are the Zipper, and then the Weekender sticker as well, which you can put on the side of the fuselage. But what we did is we went ahead and painted ours to try to somewhat match what we saw in the photos. And sometimes people get a little intimidated by painting EPO foam. What we found is what works really well is Rust-Oleum's American Accents. It's their Ultra Cover, 2x Ultra Cover paints. You're going to apply these in 2 misting coats just to kind of get a base foundation laid down. Very light, so you just see the color kind of applied on the foam, and then 1 final coat. So to be able to get all these lines and all the shapes cut in, what we did is we went ahead and created a template for the stickers, which is the big thing. If you notice the Zipper, one of the main features is the checkered flags that are on both of the wings. We went ahead and created a template for you guys. So all you're going to need to do is print this out on a label, a clear or transparent laser or inkjet label for the right and left wing, and then cut them out. Now what we found, and this is not a plug for the company by any means, but we've tested a lot of different labels in our different applications. There's a company out there called Laser Inkjet Labels, and we found that they actually offer a truly transparent laser and inkjet compatible label. What you'll find is if you do a laser printing on this, you can scratch it off a little bit even if you choose the lowest setting like a label, so it feeds through a lot slower and it's a higher temperature when it lays it down. So you're going to need to use a clear coat, and that's what the clear coat's here for. It's just to dust over top of the labels when they're finished, which makes them water resistant and a lot more durable. These work well also for inkjets, and you'll get actually a little better finish on an inkjet printer, a little higher resolution, but you're going to want to let it dry. And your best bet is about 12 hours. Let it dry overnight, and then see how the finish is. Go ahead and do a test run and see if it scratches off very easy. If it doesn't, then you're fine. If it does, it still wants to come off, you can again use your dusting of clear coat. And you just want to work a couple or multiple light coats until you get the gloss you're looking for. If you put it on heavy at first, it may cause the ink to bleed or run. So you want to do a couple light dusting coats to kind of get everything bonded to the surface, and then do a final finish gloss coat. We also created a couple paint templates for the left and right wing. Now what I do is I print these out on just Avery shipping labels. They're the full sheet white labels on my laser printer. And this is for the left and right wing. And all you do is cut out as indicated. And then the key is when you lay down paint on EPO, you're going to want to do a light dusting coat, a second dusting coat, as I mentioned, just kind of get it bonded down there, then do your final finish gloss coat, and then very quickly remove the label, or the paint template or whatever you've got if you're just using masking tape. You want to remove that quickly before it starts to bleed underneath the edge. And then you'll get pretty good clear lines. Now in the labels that we created for the checkered flags, I did include a dark line. If you get a really good clean line with your paint edge, if you're using an airbrush or something like that, you can just avoid these and cut around them and just cut out the labels. I included the dark line just in case most people are using spray cans like this or spray paint. You may not get the best edge on here, and the black line allows you to get a clear cut between your red accents and then the actual white wing below. For the main fuselage, we painted that as well using the same paints. This was just I just used masking tape and created a layout or a scheme that I thought looked okay for the shape of the airframe, and again kind of was a pseudo close match for the photo on the website. On the canopy, I went ahead and went simple, and if you notice where the lines connect on the canopy, I do have a nice white area here that's unpainted, which allowed me to do tape, paint the red, tape, and then paint the black without trying to put tape on top of the paint. And after this sets for about a week, it really feels, it's real durable. Now after about 3-4 days, it'll get less sticky. Kind of has a tacky feel for the first few days. And it's going to be a little more susceptible for scratches and wearing off. But give it a good 3-4 days to cure out, and you'll find it's a pretty durable finish. You'll also notice some other reviewers I know have painted, and they've painted the nose red down below. Well, this aircraft has no landing gear, so it's a belly lander. So I know I'm going to get a lot of contact with the ground and the nose. So I went ahead and left that white and worked my paint scheme up and around it. So the white will resist the grass and dirt pretty well, and it'll clean up a lot better, and it also won't scratch your paint, so your Zipper will keep looking nice and freshly painted all the time, even after several flights. So in the kit, we get all the airframe components, and we also get a small parts bag that includes a prop, some hook and loop for putting in the battery, and then also some double-sided sticky tape for putting in the receiver, as well as a 2mm by 20mm screw for fastening the main wing to the fuselage. Otherwise, we're ready to move forward. There are a couple of spinners included. If you look at the package, down deep inside of the white foam that it comes in, you'll see a couple of spinners that are facing straight down with a piece of foam in between them. Make sure you don't miss those and throw them out. They do include the spinners. You need to pull those out, and in this case I painted them red to match the nose of my aircraft. So let's go ahead and get started. Once you put the stickers on, and in fact when you get your kit out of the box, you're going to notice that there's still some EPO foam keeping the ailerons affixed to the wing, the wing trailing edge. You're going to want to cut that free, and if you also notice in between, there's like 3 different points that you don't want to cut out, which act as the hinge. It's a very thin piece of EPO foam that's molded in. So you're going to want to cut out around all of those so you get good free movement on your ailerons. Now I leave those in place first because my paint templates fit or line right up with my aileron when I put it on the wing. So I just line up my the edge of my aileron with the edge of the template, and then go ahead and do my painting. I've applied the stickers now, given those overnight to really stick to the foam well. You can use Windex to apply the stickers if you want to be able to move them around a little bit and not get an immediate adhesion. This also allows you to work the air bubbles out, so that's always kind of an old trick to use, is a little bit of Windex or glass cleaner on the label and then also on the wing, get it positioned, and then use some balsa wood or a piece of cardboard to push all the bubbles out, and then let it stick overnight and push down anything that's lifted overnight. Now that these are in place, I need to cut out around those stickers. Now again, being careful not to cut all the way through the aileron hinges, I do need to cut those stickers free. So that's the first thing I'm going to do before I start affixing everything else on my wing and connecting my servos to my radio system and trying to move those control surfaces. So let's go ahead and prep the wing first, and then we'll move on with the assembly. So now that I've freed up the sticker on the front and also cleared out the molding, residual molding on either end of the aileron, I removed the linkage in the back from the control horn, and just move the aileron through its range of motion so you don't get any sort of binding from your servo. We want that aileron nice and free moving before we actually apply power to the servos. The next step is to install the horizontal stabilizer in the fuselage. You can go without any sort of adhesive in this step. We're going to go ahead and use a little bit of adhesive to make sure that our horizontal stabilizer stays in place. And it's really primarily if we're flying and we come down, since this is a belly lander, there's a good chance there's going to be contact with the edge of the horizontal stabilizer, which could knock it out of place, and we don't notice that until we go to fly again, and all of a sudden we have an uncontrollable aircraft. So what I'd recommend doing is using a little bit of medium CA. This is just regular CA. It's not foam safe. Since this is EPO foam, it does not react negatively to regular CA. And what I'm going to do is I get it close to the insertion location. You see there's a small detent right there on the horizontal stabilizer, and then there's a small knob on the inside of the fuselage. So those two are going to lock in place. What I'm going to do is get this close to being in place, apply a little bit of CA to just one side, and then go ahead and insert it. Now since this is foam, foam doesn't hold moisture at all, and foam and moisture is what's required to make CA or cyanoacrylate adhere or set up. So since this is foam, there's no moisture, it's going to take a little bit longer for it to cure. What I've done before is applied a little bit of accelerator to the one side, just to the one side of the joint, dry it, allow the accelerator to dry, and then I insert it in place and apply a little bit of glue. In this case, I've got plenty of time, so what I'm going to do is get it just short of its final resting place and put a small bead of cyanoacrylate into the joint and then pull it through when I insert the horizontal stabilizer in place. If I pull through from the back side, it's now in its location where I want it to be, and the glue's disappeared into the joint for the most part. There's a little bit on the edge, but that's okay. Now that my horizontal stabilizer is nice and straight, just make sure you have equal gap on both sides. I'm going to go ahead and let that set for a minute and cure. Now I want to fix our linkage to our control horn, so we're going to go ahead and back the screw off a little bit. There we go. And now I'm going to go ahead and leave this loose for now. Pull my servo back a little bit. I'm going to go ahead and leave that loose because I need to connect my radio system and establish center for the servo before I can lock down this set screw. Because if I lock it down now and establish the radio connection, it may all of a sudden find that the servo is in a position that already has me into a significant deflection. I'm going to have to adjust it anyway, so just slide the rod through for now. And now it's time to install the main wing. So all we're going to do is feed the 2 aileron servo leads up through the fuselage. There's a hole right there, so we want to insert these radio leads in through that hole. Once they're in place, you just put the front tab of the wing. You see there's a tab right there. We just want to put that tab into the fuselage. Make sure it's all the way forward, and then put our wing in place. A little 2mm screw goes in the small hole at the bottom. Use our Phillips screwdriver. You don't want to over tighten it, just take it to where it feels fairly snug, and you start to see it pull the nylon washer down into the foam just a little bit. And now our wing is secured. The next step is to install the spinner onto the prop. Just make sure that your prop nut is tight from the factory. And then what you can do is, it's just a friction fit spinner, so it just slips on. But there's a pretty good chance that could get knocked off just in transit. So what you can do is put a very small amount of CA on the top side of the prop. Make sure you don't get it on the prop shaft or in the set screw behind it or anywhere near the front screw, the actual prop mount screw in the front, or between the washer and the prop. You want to keep that glue just on the top and bottom edge of the hub of the prop. And this is going to give you a little bit of purchase on the spinner to help keep it in place so it doesn't fall off accidentally. Now once you've applied your glue, make sure that you've pressed your spinner on firmly, and then go ahead and rotate it to make sure it's not wobbling or offset on that prop, because once you get it in place, it can be a little more difficult with the glue on there. Ours looks pretty good, so we're going to go ahead and let that cure for a few minutes. Since we're going to be using our Aurora 9X, it's important that we set it to the right protocol for the Minima 6L receiver that we're going to be using. So we need to create an aircraft profile first. We've already done that. I created one, set it up as a zipper, chose my aileron configuration. So go ahead and choose yes. And the important thing is on the Aurora 9X, you have an option of choosing which protocol. It's either going to be an AFHSS that's compatible with Minima or the Optima series receivers, or it's going to be AFHSS is compatible with the Maxima, which is their new digital-only receiver, or it's going to also support SLT protocols. So if we go into the settings, we can verify. We have a Spectra module option. We click on Spectra, and right there we have Opti and Mini, or Optima and Minima selected. We can optionally choose the Maxima. Again, digital-only servos connected to the Maxima receivers. Otherwise, you'll fry your analog servos. And then there's SLT protocol as well, which is Secure Link technology. Now, the cool thing about that is all the TXR aircraft you see out there that are transmitter ready, that normally you can connect with, say, a Tactic radio system. This supports Tactic's protocol as well, so you can use your Aurora 9X to connect to your TXR aircraft. So we're going to go ahead and make sure that we're still on Optima and Minima receivers, and all I'm going to do is choose binding, and then I'm going to turn on. I went ahead and connected a battery and a power line to my Minima SL receiver. I'm going to go ahead and hold down the link button, turn on the receiver, and it's going to go ahead and link up. So let's go ahead and choose binding, and we're going to bind to a Minima SL, so we'll choose Minima. And are you sure? Yes, we're sure. And press and hold RX link button and power up, release, and press OK when binding stops. So we're going to hold down our Minima 6L's link button, power it up, and you'll see red, and you'll see the green and red flashing on the transmitter. Release my button, and there we go. We've got a solid blue light, and now we need to cycle out everything. So I'm going to go ahead and turn off my receiver, turn off my transmitter, and since I'm on the bench with nothing connected, I'm going to go ahead and transmit first here, and then turn on my receiver, and you'll see that it has a solid blue LED indicating that it is linked. So now it's ready to go in our aircraft. With my transmitter and receiver ID linked now, I need to know which channels to plug in the servos inside the zipper into my Minima 6L. I have channel indications on the receiver itself listed here. If I go into my settings on my Aurora 9X, I'll see an option for channel. I choose channel, and that's going to list out where everything should connect. Since I told it during the model setup to choose 2 aileron servos instead of 1. Normally you do 1 and put a Y connector on there, and then they would just operate in opposite directions. This gives me independent trim, sub-trim adjustments, and everything else on my aileron. So I told it, give me 2 aileron connections and then a normal tail. So aileron 1 is going to go into channel 1, and aileron 2 is going to go into channel 5. So all I do is match that up on my minima receiver and then connect as normal. Your elevator is going to go into channel 2 is your elevator. Throttle or your ESC is going to go into channel 3, and so on. So since we only have aileron and elevator controls on this aircraft, we don't have a rudder connection. We ignore every other connection. We're just going to focus on aileron 1, aileron 2, elevator, and throttle. With all the servos connected to the Minima 6L receiver, we went ahead and powered up the system, and now we can verify that we have the right orientation or right direction on our control surfaces. If we look in mode 2, which is most common in North America, we're going to look at the right stick. Right stick to the right should make the left wing from the rear view should make the aileron go down, and likewise the right wing should be going up. So now we know we have it reversed. So we're going to reverse it in the radio system, both of those channels, channel 1 and channel 5. So now we've reversed both the channels, channel 1 and channel 5. So when we go right stick right, we have the right deflection going on. But now we see that we have one aileron offset. It's hanging way down. This should be level with the trailing edge of the wing. Likewise, we can verify that the left aileron, which looks pretty good, it's a little bit high, is level with the trailing edge of the wing as well. So what we're going to do now is go into the sub-trims. Since the linkage on the zipper is a fixed linkage, it's not an adjustable like the linkage in the back for the elevator. We need to stick with what's there, and we just need to adjust the servo accordingly. So we'll go into the sub-trim settings. So since our right aileron is connected to channel 1, we're going to go into the sub-trim menu, and we're going to choose that servo. And we're going to go ahead and adjust negative or positive. And it doesn't matter which one you start with. Just see which way it takes the servo at first. Okay, that's making it worse, so we need to go over to the positive. And we're going to sub-trim it up until that servo, that control surface, looks pretty level with the trailing edge. There we go. We got it pretty close now. Go ahead and move the servo a few times through its range of motion and see if it centers back to where it needs to be. If not, you can make further adjustments. Do the same on your left aileron if necessary. And with the radio system connected, we can verify some movement on our elevator servo, make sure that that control rod is going up and down. So we can go ahead and allow it to center out and then tighten up our set screw on our linkage. Now with the linkage tightened down on our control rod and what looks to be a nice level elevator, we can go ahead and verify movement, and we're going to check orientation. So we'll put the aircraft, looking at the back of the aircraft, when we, again in mode 2, when we pull down on the right stick, let's get this over here. When we pull down on the right stick, we should see that elevator deflect up, which it does. When we push forward, it deflects downward. So we have proper movement on our elevator, and we have proper movement on our ailerons. All we need to do now is verify motor operation. As we move our stick up, our left stick up, we've got movement on our motor. Now to get ready for the next step, I went ahead and prepped the fuselage dry fit the battery. Again, we're using a 480 milliamp 3S. It's a G8 ProLite 25C from Thunder Power. This fits nicely up inside the nose of the fuselage. What I did find is that from the factory, the ESC was back a little ways from the nose. It was actually mounted back right about here. So I went ahead and pulled that off the fuselage, scooted it forward so I had plenty of slack in my brushless motor wiring. I don't want to inadvertently unplug my ESC from the motor when I slip the battery in, so I made sure that the wires laid smooth across the bottom and then fit along the firewall so I can slip my battery in and out now easily without disconnecting any wiring. So I'm going to go ahead and dry fit my 480 milliamp battery. There it is. And you're going to want that all the way forward as far as it'll go. Now we're going to permanently affix our receiver into the aircraft. I'm going to use our double-sided sticky foam tape that they included with the kit. It's a small square pad. And I'm going to go ahead and mount it with the pins facing forward as I have here, because it gives me the option of putting my antennas back through the fuselage and keeping those antennas away from the power plant, which is always a good idea. So we'll go ahead and mount the receiver in place. And now with my receiver mounted, the next thing is to put the canopy on and to check our CG, or center of gravity. The instruction manual indicates the center of gravity to use for reference is the servo leads going out to the ailerons, the actual wires that are embedded in the wing. What we need to do though is check the CG on this aircraft. Since this is a low-wing aircraft, we need to check the CG inverted. So we need to transfer those CG lines over to the top side of the wing. I went ahead and measured out based on where those servo wire traces are. If we take there's a compound angle on the leading edge. If you go from the root and then join the intersection right there, at the intersection, measure directly or straight up 35.5 millimeter. So we want to be exactly straight up from that intersection at 35.5 millimeter, make a small dot. Do that on both sides of the wing, 35.5 millimeter, and then we're going to use that as a reference point for checking our CG. I moved our stock battery back about 3/8 of an inch from the firewall, and now when I hold it level and release, it wants to go just nose down, which is perfect. You want forward CG on your zipper before initial flight. You can always adjust it afterwards if you want more performance or you're not happy with the placement, but always start with a little bit of nose forward weight or CG placement. That's going to give you the most stability, especially on a sport aircraft, a low-wing sport aircraft. You never want to be neutral or even aft CG. It's going to make the plane far too unstable and uncontrollable. All we have left on ours is to put on our stickers that shipped with the kit. I'm going to take my extra pieces out in the field since we're ready for review testing. Not uncommon to break a prop, especially on a belly lander. If it stops in a down position, it may snap that prop off. But if you have any questions, you can go to the HiTech website at hitechrcd.com and look under the zipper for additional information. We'll send those files over for the paint templates and also the finish line or checkered flag stickers so you can dress yours out a little bit more like they show in the photos. I'm Kurt with Two Brothers Hobby. Thanks for watching and good luck with your zipper.